Welcome back. You'll notice that this is a repeat of one of the previous examples, but I wanted to show you an alternative way to approach this because sometimes we need to see the picture in terms of a triangle, right triangle, I'll say, and this should help us out when we get into inverse trig functions as well. So see what you like. So I'm going to start off again with reminding myself where I'm located. And right here, they're telling us if cosine of t is negative 8 over 17 and 0 is less than t is less than pi, then we kind of remind ourselves where t is located. It's in between 0 and pi. And so that leaves us with being located in quadrant 1 and quadrant 2. And the fact that we have a negative sign, or a negative cosine, we're actually in quadrant 2. If it was a positive cosine, we would definitely be in quadrant 1. So right away, we kind of know the location of our t, our angle t. And to kind of give you an idea, remember, if we're looking at this in terms of right triangle trigonometry, we kind of remind ourselves that we are looking at the triangle in the sense, I'll draw this over here, nice little right triangle, not to scale, but if you want to do it, feel free to. And they're telling us information about the sides of the triangle given angle t. So if you remember, and maybe this is looking a little bit forward into the next section or so, but might as well look at it now, they are saying cosine, or they're referring to cosine. And if you remember, cosine in terms of triangle sides, cosine is adjacent over hypotenuse. And so if we look at the fact that we're given 8 over 17, I'll deal with the negative sign in a second. That means the side adjacent to t would be an 8. And the hypotenuse of the triangle, that's across from the right angle, would be a 17. So this is very helpful in terms of knowing the sides of the right triangle. And I'll go even a little bit further. Remember, because they're giving us a negative sign, I believe we're looking at this in terms of if we were superimposing this right triangle on the coordinate system. And so kind of using the idea hypotenuse is our radius, and see if I can also maybe write that in for you. They usually talk about cosine dealing with x, hypotenuse dealing with r. X and y have directions sometimes, whether you're going negative or positive, but the radius is always positive. So we can assume that that negative sign has to go with the 8. So we'll get back to that in a second, but as long as you kind of know where your angle t is located, you can always go back and figure out where the sign should be on the certain trig functions. Okay, now having said this, I'm going to take this triangle and just kind of move it away so I can talk about it a little bit more. If we know what cosine of t is, we can now use the fact that we have a right triangle and we have a leg that's 8 and a hypotenuse that's 17, and we can use a Pythagorean theorem to help us figure out what that other side is. And so you can use a different letter since we're already dealing with x and r. At least that's how I've set up the triangle in terms of definitions. That must be that we have a side y that is missing. So if you'd like to remind yourselves Pythagorean theorem is telling us that the leg square plus the other leg square is equal to r squared. And we already know what 8 is, or x is. So we have 8 squared plus y squared equals 17 squared. So that leaves us with 64 plus y squared equals 17 squared. Get out that calculator, is 289. Now we can solve for y by subtracting 64 on both sides. So if I do that, that will give me 289, take away 64 will give me 225. And if you want to solve for y, you'd be taking the square root of both sides. And always have to remember the plus or minus because I'll deal with that in a second. So we're going to get y equals plus or minus, and square root of 225 happens to be a nice perfect square there. So we have ourselves a 15. Use your calculator if you're not sure. Now, if you remember what quadrant you're in, we can then kind of decide, should our y be positive or negative? Well, before we even go there, figure out what trig function you want to approach. So I'm going to go with the fact that if we're using the side of the triangle, we do know that the y, the value should be 15. And then we'll talk about the sign in a second. By sign, I mean, is it plus or minus? So let's go ahead and calculate sine of t. So my next natural approach from here. And I can use the idea now. I can use kind of the legs of the triangle to help me out. That sine is always the opposite over the hypotenuse. And if you'd like to relate it to y's and r's, that would leave us with y and r, y over r. So in our case, we're going to look at our triangle that we have just drawn, and we look at t. The side opposite is 15, and the hypotenuse, which is r, which is 17. Now, if you want to figure out, should I have a positive or negative sign? You know, r is always going to be positive because it is the radius of the circle. The rest of the x or y's, those could be positive or negatives. But let's just look at where we're located again. We are in quadrant 2. And if we're in quadrant 2, the sign is always positive. So that gives us a heads up. You don't really have to write this in, but I'm reminding myself that the sign is positive, and that gives me a heads up that since we're in quadrant 2, y is going to be a positive number. No, but really I do look at the trig functions. I don't really try to determine it until I'm actually calculating. So I've got cosine t, I've got sine of t. I can now do either I can go off the cofunctions, or I can look at maybe tangent. That's the next natural thing to go with. So let's do that. Tangent of t. You could either use identities where tangent is sine of t over cosine of t. You could also use the relationships to the legs of the triangle. Tangent of t is opposite over adjacent. So now if you're looking back at your trusty triangle, the opposite side of t is 15, and the adjacent side of t is 8. And then if you're trying to figure out the signs, well, you can either go the fact that you already figured out that 8's negative and 15's positive, or you can look at the fact that you're in quadrant 2. So in quadrant 2, the only positive trig function would be sine and its cofunction cosecant. So tangent of t, if we're in quadrant 2, should be negative. Now feel free. We can find the rest of the trig functions. If you want to go backwards, it's okay. But I'm just going to go through and give myself the idea. If I know that cosine of t is negative 8 over 17, I can then use that to determine what secant of t is. We can use the idea that we have a reciprocal identity Or you can use the fact that, well, if cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. So secant of t is 17 over 8, and we should be negative. Similarly, I have sine of t, which we calculated as 15 over 17. If you'd like to use the cofunction, we have cosecant of t. And if we're using the fact that sine of t is opposite over hypotenuse, then cosecant of t is hypotenuse over opposite, or the reciprocal of the sine. So we should have 17 over 15. And then finally, if we're looking at tangent of t, which is negative 15 over 8, we can now use the fact that we're looking at cotangent of t, and we're looking at the reciprocal of tangent. So this is going to give us 8 over 15, and don't forget that we have negative. So now we have the values of all 5 remaining trig functions if we know cosine. And it's just another alternative way to take it based on the labeling the legs of a right triangle. So I find this a lot more useful to myself. It's a lot less math to me, but kind of get to play around with both techniques and see what you like better. But I do see this a lot when I start dealing with inverse trig functions. So I hope this helps. I'll see you in the next example.